All right, welcome to, this is our 6th snow day if you're watching this, which means we might have to make this one up, which means we're probably less excited about it. I'm still excited about it. I would like as many snow days as possible. But this is going to be a shorter video. Stick with me till the end because there's good news at the end of this video for you as well. The main thing I want to talk about today is how to take one of these polar equations and find the area under a polar curve. This is your formula. You just need to remember this formula. You don't really want to know where it came from, to be honest with you. There's theory about it in the book, but you're really better off just remembering to find the area under a polar curve. We take an integral just like we do for any area, but the thing that we're integrating is 1/2 r squared d theta. So this is the formula you should remember. The bad news about this formula is d theta is our operator, so our expression should be in terms of theta. And right now it's not. The good news though is this is in terms of r and theta, which means we don't have to deal with finding x and y. We don't have to go back to that r cosine theta and r sine theta. We usually have r in terms of theta in the problem. But we do need this expression to be in terms of theta before we integrate, so we just have one variable that we're dealing with. But integrate 1/2 r squared d theta on whatever our bounds are. For your example problem in this video, I actually took one of your homework problems. This is question 6. So if you want to find question 6 in your packet there, we're supposed to find the area of the shaded region in this problem. This is the graph of r equals 1 plus cosine theta. It's a little bit more circular on this side in the packet. But we're supposed to find the area of this shaded region. In order to do that, we know our formula is 1/2 r squared. Right, it's 1/2 r squared d theta that we're going to be integrating. First, we need our bounds, and remember your bounds are being in terms of theta. So look at what angles are being included as we go from here to here on the graph to enclose this shaded region. We start over here at the angle 0. And then we go all the way through to pi. So our bounds in this problem are going to be from 0 to pi. All right, it's 1/2 r squared d theta. Since r is this expression, we're just going to plug that in. 1 plus cosine of theta squared with respect to theta. That's your setup. Put that in your calculator. And by the way, we haven't really talked too much about calculators yet, on the videos at least, since we've got to talk about them in class in between. You do not need to change your calculator into polar mode to do any of these things. You can leave this in terms of x if you want and just integrate dx, make that an x. Your bounds being 0 to pi, it's all going to be fine if you just leave that in terms of what you have there. Oh yes. The bells are still ringing. So we're going to go and put this in your calculator. I've got the number out of my calculator here. I think the answer book says, I know you can't see me right now, the answer book says 3 pi over 4. That in the calculator that comes out to 2.356. 3 pi over 4 is fine, but you are not going to integrate that by hand. You'll never be asked to, nor should you want to, honestly, because that would involve getting some trig identities included in that. So 1/2 the radius squared d theta, that's everything. The good news for you is you're not going to do all the problems that are in the assignment. The more I looked, the book wants you to do some things with the calculator with polar, and I don't want you to get into that. If we've got time at the end, maybe we will, but I want to deal with just the stuff that you need to do on the AP exam in these videos. So all you need to do in that section 10.4 is just 1 through 8. We actually did 6 together just now. Those all deal with one area under a curve, under a polar curve. When we get two equations together, we'll see those in the AP problems, and we'll tackle those there. I'd rather do those the way the AP exam would like us to rather than the way the book did. So just do 1 through 8 for me, please, and have a great day.